In this demonstration, we will use Cosmos FlowWorks to calculate the pressure drop inside the ball valve. Cosmos FlowWorks uses 4 easy steps to solve the problem. 1. Problem definition using a wizard. 2. Specifying boundary conditions. 3. Specifying goals. 4. Solving and viewing results. Cosmos FlowWorks uses SolidWorks configuration for flow analysis. Using the wizard, we'll specify the SolidWorks configuration and analysis units. Next, we'll specify the flow to be internal. We also specify water as a working substance from a database of predefined liquids and gases. After the completion of setup, we'll assign proper boundary conditions. Cosmos FlowWorks automatically detects the fluid volume boundary and plots it on the screen. We can choose to hide the fluid volume boundary. As a boundary condition, we specify a mass flow rate of 0.5 kilograms per second at the inlet. At the outlet, we specify a pressure boundary condition and we set the pressure to be equal to atmospheric pressure. Next, we specify the goals for this problem. To measure the pressure drop, we ask the software to give us the average static pressure at the inlet and at the outlet. Next, we specify an equation goal to calculate the pressure drop. We can rename the equation goal as pressure drop. Then we go ahead and run the solver. Cosmos FlowWorks automatically measures the fluid volume and solves the problem. Once the problem is solved, we close the solver to look at the result plots. Cosmos FlowWorks offers a variety of result processing capabilities. Let us look at a section plot of the pressure. We can plot the velocity vectors on the section plot. We can also do other operations like changing the vector spacing and the size of the vectors. Next, we will create a flow trajectory plot to monitor the flow of water inside the valve. We can also animate the trajectory. And can save the plot as an AVI file. Next, we will examine the goals. We can ask the program to give the pressure drop in Microsoft Excel format. Note the pressure drop as 28620 Pascal. We will now perform a design change inside SolidWorks and then use Cosmos FlowWorks to give us the new pressure drop. We will create a new configuration in SolidWorks and call it CFD2. In this configuration, we will change the angle of opening to 25 degrees. We will then go back to the original configuration and clone the existing Cosmos FlowWork project to the new configuration. Cosmos FlowWorks automatically detects a change in geometry and rebuilds the new fluid volume. All the boundary conditions and goals that were applied previously were preserved to avoid any duplication of efforts. Now we can simply run the problem, and once the calculations are finished, we can view the results for the new configuration. Notice a new pressure drop of 84311 Pascal compared to the previous pressure drop of 28620 Pascal. Finally, we can use any existing sketch of SolidWork to plot the variation of result quantities like pressure, velocity, etc. along the sketch. In this example, we will plot the pressure and velocity along a predefined sketch. All results can be saved in Microsoft Excel format.